Welcome to this video. In this video, we will be using built-in transformation in Altair to provide visualizations to answer the same questions that we have addressed in the previous session. This exercise uses the Titanic dataset, and we're going to create visualizations to answer several questions. Let's take a look at these questions. How did survival depend on sex and class? So, in the previous video, we used pandas to do a group by operation, and then we reset the index, and we used Altair on the new data data frame to create the visualization. Here we're going to use the built-in data transformations in Altair. What I want to do here, I want to create a chart that relates observations from these two categories. And that relation should show the propensity of the frequency of observations falling across these categories: female first, female second, female third, and so on. I'm going to start here by creating a bar chart, and I'm going to use two encoding channels. I'm going to make my X to be the class and my Y to be sex in this case. What I do get here, I do get 6 squares. That basically tells me that there are observations in each combination of these categories. Now I want to show the propensity of these observations, so instead of using the same color, I'm going to map the color to be something like count. That basically will count the observations falling in the intersection of these different values of the two categories, and will be mapped to the color. So we can see that most of the observation fall underneath the third male. Now notice that survive here is a variable that takes two values, 0 and 1. So if you sum that variable, you get the number of people who survived in each one of these groups. Let's say you don't want to have the count, you just want to have the percentage of people who survived in each one of these categories. Instead of using count, I'm going to do average. And again, noting that survived is a variable that takes two values, 0 and 1. The average will be basically the percentage of people who survived. And we can see that it ranged from 0.1 to 1. Now, in contrast to the old chart, we can see that survival was kind of more prevalent for female passengers, especially those in the first and the second class. The second question is asking us about the distribution of passengers index. So that question is asking us to create a histogram, and we created such histogram in the past by using pandas, doing the count, and then using a bar chart. What I'm going to do now, I'm going to use Altair to do this histogram, doing the count transformation. Now notice that the deck is a categorical variable, so I don't need to bin anything. I just need to count observation in each one of the categories. So what I'm going to do, I'm going to chart data, and then I'm going to mark bar, and I'm going here to encode my X to be the deck and my Y to be the count. That's basically the number of observations in each one of these decks. Now notice that we have some null values. So some observations we don't have information about the decks. And actually it seems that most of the observations we'd have no idea about the deck. That probably explains why when we did this heat map, when we did the sum, actually the first one, if we do count here, we did not find many observations in some combinations, such as the second class and the third class. It seems that it's kind of probably driven by the lack of information rather than the existence of such information. So probably most people were in the third class, maybe in lower decks, but we have no idea about these people. Alright, so let's take a look here. I mean, that's the histogram, except that we have this null value. And again, here we have an option to do filtering using pandas. So we can, if we wish, drop NA. Dropping NA is here very restrictive because it will drop any row that has any NA, including in deck or outside decks. We can do that certainly if we wish so, or we can use another transformation in Altair. Before encoding, I'm going just to filter the data using a transformation called transform filter. This transformation basically allows us to filter the data before encoding it. Each observation is called datum here, and what I want to say here is datum.deck is not equal to null. This may seem a bit arcane. It has to do with the fact that underneath the hood, Altair uses Vega, which is a visualization engine in JavaScript. So there is kind of definitely some heritage here, but we can use this kind of shortcut whenever we want a certain variable not to be null. We can definitely do the transform filter before encoding the data. And we get the histogram here. The question here is asking us of whether a deck correlate with class. So we've done this in pandas by grouping by deck and class and then counting the observation in each intersection of these two categories. What I'm going to do here instead, I'm going to create heat map. I'm going to start by creating my chart. It's going to be a bar chart. And I'm going to encode the X to be the deck and the Y to be the class. That will show me that they are a combination of these decks and classes. Some combinations do not exist, such as first class and F and G. I also noticed that for those observations without a deck, I got the null value here. Let me take care of the null. I'm going actually just to copy and paste the transform filter from above. That basically will filter the data before encoding it. Okay. Now, second, my color would be the count of observation in each one of these categories. So color will be count. That will basically create a heat map showing the propensity of the frequencies of observations falling in the intersection of the class and the different decks. Another way to do this is to transform the data completely before encoding it. So this is an advanced example, but it's basically kind of shows you what's going under the hood. I'm going to transform filter here, but after transforming filter, I'm going to use another transformation called transform aggregate. And this transformation allows me to create a new variable. I'm going to call my new variable passengers. And my new variable will be the count. The count of what? Count of observation, grouping by deck and class. And then once I'm done with this one, I can encode my X to be the deck, my Y to be the class, and the color here will be just the number of passengers. So I'm going to do passengers here, and I'm going to make it quantitative. That basically will create a similar heat map to the one above. What's the difference? The difference here is that this is doing the encoding on its own, so plugging in the default values. Transform aggregate. Let's look at the last question. How did survival depend on deck? That's very similar to the previous question, except that instead of using count, I want to use the sum of survive or the mean of survive. So I'm going to do something similar. I'm going to create a histogram. I'm going to do altair.chart data mark bar, and I'm going here to encode my x to be the deck and y to be either sum or average if I want to create the percentage of survived. That will basically show me the percentage of observations, the average value of the variable survived in each one of these categories. Again, I got that pesky null bar. I can live with it, and this will show that, well, if we don't know the deck in passengers for whom the deck was unknown, the percentage, the average of survived is 0.3, or I can use the transform filter here and take out that null value. So I can transform filter before plotting it. So this concludes this exercise. Once again, we've done this exercise using transformation in pandas prior to using Altair. Altair provides its own set of transformations. Again, this provides you options, and it depends on your familiarity with each one of the tools.